Hi, my name is Heather Hanslick, and I'm excited to present a research project on Nickajack Dam and some of the impacts that this dam has had on biodiversity. Biodiversity is the variety of a life in the world or in a particular habitat or ecosystem. Over the past few weeks, I've been working along two 30-meter transect lines of two different habitats, a marsh and a creek, only 20 meters away from one another. I used a 23.5 centimeter by 4.29 centimeter quadrant to take a random sample from each. I was amazed by the biodiversity of plant life. I found 34 different plant species in one sample plot and 19 in the other, with only one species in common between the two. This is a great example of the variety of life in two particular habitats, and here are some of my photos. Unfortunately, there are many drivers that can lead to biodiversity loss, and the primary drivers of biodiversity loss are habitat loss, agricultural farming, particularly cattle and the food to grow to feed them. All farming can lead to the destruction of nutrients in our soil, especially if farming isn't suitable, as is often the case. Fragmenting separates plots of land, leading to species separation and forest edging. This can greatly reduce a species' livable habitat and limit their opportunity for genetic diversity. Overexploitation, when harvesting exceeds reproduction of wild plants and animal species, this practice depletes stocks and can lead to the extinction of species. Global warming, the rising levels of greenhouse gases have led to a changing climate on Earth. So much of the life on Earth unable to adapt to these changes. And some of them are affected by too much water or lack of water, loss of surrounding plants and animals, and maybe the temperature is just too hot or too cold. Pollution is the introduction of substances into our environment that are harmful or poisonous in it. This can be something natural like volcanic ash or man-made like polychlorinated biphenyls, which I'll mention again a little bit later in my presentation. Invasive species, these are non-native species that can significantly modify or disrupt an ecosystem. I'd like to mention that taking land from natives also influences biodiversity loss, and I'd like to reintroduce my topic of Nickajack Dam with a brief history. Prior to the white settlers, this land had been occupied for several thousand years by Historic Creek and Cherokee Indians. The Cherokee claimed this land in the reservoir area, but the Jackson and McMinn Treaty of 1817 allowed settlement of Marion County, Tennessee, by transferring the land from the Cherokee to the U.S. government. Claims for land continued to grow quickly by white settlers, and in 1836 the U.S. Senate created the Treaty of New Echota and began removing Cherokee Indians in 1838, along what is known as the Trail of Tears. Creeks, Chickasaws, and Choctaws were removed as well. Nickajack Dam is located in Marion County, Tennessee, with a surrounding reservoir located in counties of Marion and Hamilton of Tennessee. This reservoir is the sixth step in the stairway of Tennessee Valley Authority's reservoirs that lock and carry barges up and down the Tennessee River. It stretches 46 miles upstream from the Chickamauga Dam, and you can see that here. This is the Nickajack Dam, and here are the 46 miles that are in between, and there's the Chickamauga Dam. The dam is 3,767 feet long with a max height of 95 feet. It is constructed of a combination of concrete gravity spillways and earth embankment. The spillway consists of 10 gate openings, as shown here, that are 40 feet wide and separated by 7.5 foot thick piers. These are the piers, located approximately in the middle of the original riverbed. Hydroelectric facilities such as Nickajack Dam cause frequent changes in water levels. This has a dramatic effect on sensitive microorganisms, but also larger organisms that may have spawning beds. Dams significantly impact fish migration. Even with fish passage structures intact, only a percentage can pass through, which will ultimately limit their ability to spawn, hide, and search for food. Reservoir pools can be disorienting to migrating fish as well and increase their duration. Increased duration leads to changes in growth, reproduction cycles, which impact predator and prey relationships. For microorganisms to fish, plants, and birds, reptiles, and small amphibians, the food web just becomes altered. And this imbalance can be seen in a variety of ways. Loss of biodiversity is most obvious, but sometimes it happens because a plant or animal once controlled grows out of proportion. Such is the case for a huge increase in algal blooms in the Nickajack Reservoir. This greatly decreases the oxygen levels in the water, and this nutrient-rich water, along with an increase in sediment, has become too polluted to sustain life for the once thriving Anthony's River snail. According to the Nickajack Reservoir Land Management Plant Regional Overview, in 2016, the Tennessee Department of Environment and Conservation, which establishes water quality standards for 7 designated uses, listed the entire length of the Nickajack Reservoir as impaired due to sediment contamination by polychlorinated biphenyls and dioxin. This information is included in a 303D list from the TCDE. In this same land management plan overview, Anthony's River snail was one among several gastropods listed federally endangered and critically imperiled, with 5 or fewer occurrences by state rankings. Multiple species of mussels made the list as well, and since Anthony's River snail historically had such a strong presence prior to impoundment, experimental populations were introduced along various parts of the Tennessee River in 1991, 2001, 2006, and 2007, but without advancement. These are just a few impacts made by implementation of this dam. I'd like to discuss my concerns with the field officer of the U.S. Field and Wildlife Service, particularly for the impact of the Nickajack Dam impoundment on the biodiversity loss of gastropods and mussels, and petition to start a conservation project for some of the existing but depleted populations. The U.S. FWS provides assistance toward many conservation efforts, including conservation banking and fish passage technical and planning assistance. Conservation banking consists of a partnership between a landowner, a government agency or developer, and those trying to conserve a species in their habitat. Fish passage technical and planning assistance provides financial and technical assistance for projects improving the ability of fish or other aquatic species, such as snails, to migrate through barriers, such as dams. Here is a framework model I created of some of the human and anthropogenic factors, as well as some of the ecological and environmental factors of the presence of the Nickajack Dam. The human and anthropogenic factors pertain to the factors that are caused by humans. A dam's purpose is to block and hold water for a variety of reasons, only allowing a specified amount of water through allotted channels. This leads to degraded water quality and sedimentation, like we discussed earlier. The stored water naturally brings debris with it, which settles when it comes to an abrupt stop. As we know from the regional overview, the Nickajack Reservoir sediment is full of polychlorinated biphenyls and dioxin. Water temperatures are changed. The water flowing out of the dam is warmer than the water in the reservoir, and our greenhouse gases continue to affect rainfall amounts, leading to power unreliability in hydroelectric dam systems. Some of the ecological and environmental factors include the obstruction of fish migration, which is inevitable with damming. Only some of the fish will have the opportunity to get through the dam. The river flow is disrupted. Habitat degradation can occur when fish spawning locations are disrupted by dam flow and altering water levels. Eutrophication is caused by an abundance of nutrients, and you can see these out-of-control algae blooms in the photo that I took at the Nickajack Reservoir. These water conditions can lead to the eradication of species, such as the case for Anthony's River snail. A few of TVA's past management practices include educating farmers on how to stop soil erosion. TVA helped restore forests, and they assisted in controlling water pollution, but I would consider that more monitoring because they monitored pollution levels of phosphorus and dissolved oxygen, phytoplankton, and algae blooms. TVA's current management practices are much better than they were in the past. They review and improve current operation practices to reduce costs and enhance biodiversity, partner with local, state, and federal and nonprofit organizations. This is where a conservation project backed by the U.S. FWS can come into play. They engage local power companies on issues, opportunities involving biodiversity and operations, communicate both internally and externally the full suite of what ongoing biodiversity conservation work at TVA to build an understanding of the value and significance of this work. They establish and maintain a biodiversity action team, including representation from across TVA to highlight ongoing conservation efforts and minimize the adverse impact of TVA operations systems, including by protecting endangered species. I have created a side-by-side, a page from an EPA report on the eutrophic conditions of the water in the reservoir at Nickajack Dam in 1977 versus a photo of the eutrophic state of the Nickajack Reservoir water that I took near the end of 2022. I conclude that very little practice has improved the reservoir water quality, and we can see that as a factor in the decline of species as well. Proposed solution. Species like Anthony snell will thrive along banks of the river, feeding on detritus and an array of microorganisms, aiding as a perfect natural filtration system. When this water becomes too nutrient-filled, these aquatic snails will grow faster, far too fast, and die quickly, or just become really healthy and not be able to survive due to the lack of oxygen. This water clearly needs more oxygen. One study I read titled The Effects of Snails, Submerged Plants and Their Coexistence on Eutrophic and Aquatic Ecosystems resulted in a combination of submerged plants with aquatic snails yielding significant improvement to water quality. The total nitrogen, phosphorus, and chlorophyll A were sampled with this treatment every 2 weeks. So I propose looking at various ways to improve oxygen. Let's get back here. That would be some natural ways, like the submerged plants and non-invasive aquatic snail species, or consider some unnatural, like weirs or just some spillway modifications. I've created a shirt design to sell in an upcoming Tennessee Environmental Network show where all proceeds will go to the American River Organization, and they're matching funds for their 50th anniversary. They work to restore rivers, protect them, aid in dam removal, and conserve clean water. On the front of my shirt, you can see the Nickajack Dam with angel snail species flying from it, and the back of my shirt has some facts about biodiversity in the Southeast River system, as well as water resources and water quality complaint contacts. Where I've bridged the gap between social and natural systems has changed over the years. We don't have time to treat the impact of biodiversity loss delicately. I want to educate and encourage large groups of people to make the necessary decisions that aid in the effort to save our environment. Enforcement of laws to aid in protecting our environment are necessary. Enforcing will only feel like a sacrifice for those involved during the transition period and unrelatable to our descendants who might be raised on only sustainable options. I'll be directing a portion of my time to aid in habitat restoration and cleaner water for a species such as Anthony's river snail. Thank you so much for your time. Here's my contact information and my references.